Today's lesson, section 12.3a, we're talking about geometric sequences. A geometric sequence is a sequence of the form a, ar, ar squared, ar cubed, and so on and so forth. So the addition or the change is this value of r that increases by a power of 1 every time. So the number a is the first term, and the r is the common ratio, so kind of like the common difference in the arithmetic sequences that we did in the last section. So for this one, to find common ratio, you would need to take the term that is after the previous term on the top, and then the first term in that two values needs to be on the bottom. So then I divide them, and that gives you r. So every time, I always take like the second divided by the previous. And then, so if you have the second and the third, you take the third divided by the second. If you have the third and the fourth, it's the fourth divided by the third. So you kind of do the one after divided by the one previous. Okay? And we're always putting it in this form of a sub n is equal to a times r to the n minus 1 power. So first, example 1 says determine whether the sequence is geometric, and if it is, find the nth term of the sequence. Okay? So here, a is 27. Now to determine if it's geometric or not, I need to look at my r values and see if they're the same for each one. So then here, if I take the previous, or the after divided by the previous, that gives me negative 9 over 27. I can reduce both by 9, so that gives me negative 1 over 3. Then do the same for the next one. So 3 divided by negative 9, they're both divisible by 3, so that makes it negative 1/3 as well. And then the next one be negative 1 divided by 3. Well, that one just stays as negative 1 divided by 3. So since these are all the same, then you would say yes, it is geometric. And so your r value is negative 1/3. So now you can plug in those values to your standard form of a geometric sequence. So it would be 27 times negative 1/3 to the n minus 1 power. And those would be your answers. Example 2 says find the first 5 terms of the sequence and determine whether it is geometric. If it is geometric, find the common ratio and express the nth term of the sequence in the standard form. So here I want to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So then I get 4 plus 3 to the first, gives me 4 plus 3, which is 7. Then 4 plus 3 squared, which is 13. Then I get 4 plus 3 cubed, which is 31. Then I get 4 plus 3 to the fourth, which is 85. And then 4 plus 3 to the fifth, which is 247. Okay, so I have my first 5 terms, and now using that common ratio trick that we used last time, you want to divide those to each other. So the after divided by the previous. So in my calculator, 13 divided by 7 is 1.86. Okay, and then I do the next two. So 31 divided by 13, since these are not irreducible, or like they don't go into each other easily, then that gives me 2.38. So now, because they're not equal, then this would be no, or not geometric. Okay, because they're not equal. So you just have to prove they're not, you just have to show 2 ratios. If you want to prove that they are, using all 5, you need to make sure you go through, and because if even one doesn't match the other r values, then it's not geometric. And so you have to always check all of them. Okay. So example 3 says the first term of the geometric sequence is 3, and the third term is 4/3. we want to find the fifth term. So here we're going to set up a system of equations. We don't know r or a, but we do know n for right now, for each of them, and we do know what that term represents. So for this one we have 1 minus 1, that's supposed to equal 3. The other one, for the third term, you have 3 minus 1, and that's supposed to be 4/3. So here, 1 minus 1 is 0. Okay, so r to the 0 power is 1, so it just leaves you with 3 as a value. So that makes it easy to help you with the other one, so you can help you find what r is. So a times r squared is supposed to equal 4/3. So now I can insert that 3 in, divide both sides by 3, or multiply by the reciprocal. So that means r squared is equal to 4/9. We want a square root. So that gives me 2/3. Okay? Or plus or minus 2/3. Now, for this one, it really could be either one because you're looking at the fifth term. So it makes it hard to decide if it's supposed to be odd or even, and I'll show you here. So let's try both. So here, a sub 5, you could either have 3 times 2/3 to the 5 minus 1 power, and it's equal to, let's say, 3 times 2/3 to the 4th, and then the 4th power gets you 3 times 16 over 81. The 3's in the 81 and the 3 reduce, so it gets you 16 over 27. Now here, if you did the other one, because it's going to end up being to the 4th power, that 4th is an even power, so it gets rid of the negativity of the 2, so it makes it positive just like the other one was. So you're going to get the same answer. So it's hard to tell which one you're supposed to use because you don't have enough information to determine, or they don't really say that your r should be positive or your r should be negative in this case. So for right now, for this one, we can say 16 over 27. If they don't give you any information and you have two different answers, then you should probably just write two different answers, because it could be either one because you don't have enough information for it. But in this case, they both end up being the same, so it's just going to be 16/27 in this case. Okay? Have fun.